Every developer has said this sentence at least once, but it works on my machine. In the next few minutes, you'll understand exactly why that happens and what finally fixed it. Here's your app running happily on your laptop. It looks like one thing, but zoom in and it's really an iceberg. Your code is just the tip floating on everything underneath. To run at all, your code needs a runtime, say Node version 22. That runtime needs system libraries. Those libraries need a specific operating system, and around all of it, environment variables, config files, and network ports each set just right. Now ship that app to the production server. Different machine, different story. Your laptop runs Node 22, the server runs Node 20. Your laptop has one version of a library, the server has another. Nobody did anything wrong, the machines just drifted apart. And when the app lands on that drifted machine, crash. The code didn't change, the environment did. That is the whole mystery of works on my machine. You shipped the code, but you didn't ship its world. Multiply that by 10 apps on one server, all sharing the same system libraries. App A needs version 1, App B needs version 2. They cannot both win. Teams call this dependency hell, and for decades it was just normal. So here's the real requirement, and it sounds almost too simple. Stop shipping just the code. Ship the code together with its entire world. That's exactly what a container is. One sealed box holding your app, its runtime, its libraries, and its configuration. The box doesn't care whose machine it lands on. Inside, the world is always the same. And boxes don't fight. Each container gets its own isolated view of the system, its own files, its own processes, its own network ports. App A and App B finally stop stepping on each other. Now, if you're thinking, wait, isn't that just a virtual machine? Great question. Let's put them side by side. A virtual machine starts at the hardware, adds a hypervisor, and then, here's the key, boots an entire guest operating system for every single VM. 3 VMs, 3 complete operating systems. A container starts at the same hardware, runs one host operating system, and then every container shares that one kernel. Same isolation idea, radically less baggage. That sharing is why containers feel instant. No operating system to boot means a container starts in milliseconds and your machine can run dozens of them without breaking a sweat. You'll often hear containers are megabytes, VMs are gigabytes. Sizes vary, that's not the real point. The real difference is the guest OS. A VM carries one, a container doesn't. And to be fair, that full guest OS gives a VM a harder isolation boundary. When you need maximum separation, say running untrusted code, VMs still earn their keep. These are tools, not rivals. Containers existed in Linux for years, but using them meant wrestling with low-level kernel features. Then Docker showed up and wrapped all of it in tools a normal human can use. Watch how small the magic looks. One command, docker run nginx. Docker pulls the image, creates the container, and a web server is running. That's it. That's the whole workflow. Behind that one command, Docker downloaded an image from a registry, a shared library of prepackaged software, then unpacked it into a running container on your machine. Keep these two words straight and Docker makes sense forever. The image is the frozen blueprint, it never changes. The container is a live running copy of that blueprint. One image can stamp out 100 identical containers. And because the image is frozen, dev, test, staging and production all run the same seal package. Machines and networks still differ. This is consistency, not magic. But the biggest source of surprise is simply gone. So where do images come from? A recipe called a Dockerfile. 5 lines. Start from node 22, set a working directory, copy your code in, install dependencies and say how to start. Docker reads it, builds your image, done. That gives every team the same 3 verbs. Build the image once, ship it to a registry, run it anywhere. Laptop, server, cloud, identical every time. But be careful, containers solve packaging, not management. When you are running hundreds of containers across many servers, when they crash at 3 am, when traffic spikes, who's in charge? Nobody, yet. So that's why containers exist, because shipping code without its world was always broken. Package the world and the whole problem disappears. Next time, what happens when you have too many boxes and meet the system that conducts them all? See you there.